Hi, folks. When it comes to using beam elements in the 3D Experiences FEA module, sometimes you wonder whether you should take your structure and join it or not to join it before proceeding with the finite element calculations. So to do that, I will look at a very simple problem. Cantilever beam point, which is loaded uniformly. And I have some results here later on in future videos. I will be doing some bending moment shear force diagram generation of things like this. But I will do it three different ways. First of all, because this is a plain basically frame, I do it in a sketch. You draw that line in sketch and then proceed and join it, of course. And then I will repeat the same thing, but will not join that sketch. And you see the issues that you will run into. And finally, I will not use a sketch, do the same problem, but use it as a line and do not join, okay? In this particular problem, because it's a single line, it really doesn't matter. But when you have multiple lines coming together, the issue can be a bit different, and you can work these out at least yourself. And I've done some of the other videos. All right, this is a very common slide that I show. It allows you to display different things with the beam elements once you measure. And also, this is going to be useful later on when I do some bending moment shear force diagram. Okay. All right, let's go ahead and do that. I go here, and I'm going to start. My first problem is do it in a sketch and enjoy. Everything is going to go smoothly. So we can do that in part design or generative shape design. But if we're going to be joining something, we have to go there. Or the baby version of this was generative wireframe surfaces. Okay, so I will start with the generative shape design because I know that I need to join icon here at some point. Okay, now let me go and set my units. Let me go to preferences. I'm going to set my units here. First of all, the length, I'm going to make it inches. All right. And then the force, I'll change it into uh, pounds, lbf. Okay. For force per length, which is, let me put this thing in alphabetical order. Force per length, force per length. See, let's see if we can find this thing. Force per length. I will use yacht pound force per inch. That's already there. And for stress, I will use PSI. Okay, so let's see now. Where is stress here? Let's see. It's be somewhere here. Strain, stress, which is already PSI. I don't think we have the option of KSI here, so that's okay. I will use PSI. I don't believe we have KSI. No. Okay, that's fine. All right. So let's go ahead and create our sketch. So on that vertical plane, I will sketch a line. I'll draw the line here, and it's going to be 120 inches long. 120 inches. Good. All right. So exit. Okay. So you know what? Actually, I'll move this thing a little bit up because it's easier to see what's going on. Yeah. Very good. Now we're going to apply material to that. So let's, join. I forgot to join. Now that I did it, I can go to join it on the transform. Remember, this was the first strategy, which is create a sketch and join it. And I'm going to say fine, join it. Okay. Notice that the joint has been created here. And then I'm going to create material. So tools, create a material. I'll call it join or not to join. Join or not. Steel. It's not a big deal. It's just the standard properties of steel. So we're going to create that. And then I'm going to apply it. Join or not to join. So I'm going to apply it to this. I have to input my numbers though. So I go there. Double click. It's structural, abacus multiphysics, mechanical, elasticity, and elastic modulus 29,000. KSI, so 29,000. Yep. I can put 3 more zeros or say K here and it will convert it. Okay, good. And then cosine ratio, we don't need it, but I'm going to put it anyways. 0.3 for C. Now, this is done. So now we're going to go and mesh it. So we go to structure model creation. It's an empty FEM model. Here's the mesher, beam mesh. Each one of them will make 120 inches. Each one of them will make 12 inches. That means there's going to be 10 elements across. Yep. And then we say, okay, mesh, say, okay. Now the cross-sectional properties. So we go to properties. First, the profile, beam profile, circular, circular radius 2 inches. You can see that radius 2 inches. Yep, 2 inches. Good. And then beam section properties right there, and profile 1. And that's pretty much it. Now, when I do this problem without joining, you will see that there will be some issues in creating that section. Okay, good. Now, in the event that you want to see the cross section and everything, I don't know why you do that at this stage. So display preferences, show the cross sections as a solid right there. That's one of the slides that I put it there, but I don't want it. That's okay. It's okay. Or leave it as none. Okay, good. Now we're done here. So we're going to go to structural scenario creation. We select our FEM model, the one that we created. And for procedure, I'm going to do, because it's a very simple linear problem that I'm doing, I'll do static perturbation. Okay. And for boundary condition, clamp this end. Now notice that it's easy. I can select this. Later on in strategy 2, you see that I will not be able to select this, but here I can. So select this corner. There's the clamp. And also you go on the loads, under beam load right here, beam load. Notice that I can select this line. You will see that in strategy 2, I will not be able to do that. And apply a beam load. Downward, I think the slide said a 10 pound per inch. So minus 10, minus 10. You say, okay, there we are. And that's pretty much it. So let's go ahead and simulate, model and scenario check. No problem there. Simulation check. There will be no problem there either. But I go through the steps. Very simple problem. In video 8, when I'm going to be doing bending moment and shear force diagram for this particular geometry, I will use the third strategy as you will see. Well, that's down the road. Okay, so this is going to be close. There is a warning here, but it's not a big issue. Okay, good, good. Close that, and now I'm going to simulate. Very simple problem. It's going to bend. Everything's going to work out. And then I'm going to repeat this problem, except that I will not join that sketch. Okay? I start fresh from a new, session. Although I can use this, get rid of the join and all these things, but all right. Very simple problem, simulation, processing, extracting result, it's done. And the maximum tip deflection should be about 0.711 inches. We'll see that. Okay. This displacement, 0.71. Okay, very good. Very good. So that worked. No problem. I had it in a sketch because of the two-dimensional geometry, and I joined. I was able to take the left point. I was able to put the load on that line, and everything worked out fine. Now, I'm going to get rid of this, start fresh. I don't have to set my units anymore, etc. And I will go to, notice that I don't need joining operations, so I can do it here or here, but that's okay. I'll go to the same place. Okay, so on that vertical plane, I will sketch a line up here, 120 inches. This vertical, horizontal. I like to make it horizontal. Good. The dimension has to be 120 inches. Okay. There we are. Exit. Material I've already created, so I use that. So let me browse this. Material browser. Right here, join or not to join, remember? So I'm going to apply this. Okay. Do that. And let's get to this. Okay. Very good. Next step is to mesh it. So I go, okay, here. Let's go to the, remember, I did not join. There's no join here. Good. So I go here to the structure of models creation, MTFEM. I select this line, and under the measure, I selected that line, beam mesh, 12 inches long, mesh. No problem, just like before. Now I go to properties. First of all, create a profile, beam profile, circular, radius 2 inches, and then beam section. When I try to select this, it won't do it. It will not select this line. It will not select this line. However, notice that on this side, I have an option. It says meshed part. So I can do it like this, or I can go and select the mesh. Either way, either way. So let me go ahead and select the here meshed part, no problem. And there is the beam mesh that I created. And the profile is profile 1. And I say, okay. And let me update this. Okay. So let's go ahead and do this was the profile, right? Or properties we already applied profile. So we could not put it on the line, we had to put it on the meshed part. Now we're done here. So we go to structural scenario creation, select our finite element model. We say okay. Let's do a procedure static perturbation. Okay, fine. Now we try to put the boundary condition, the clamp at this point, right? At this point. We're trying to put the clamp at this point. So we go clamp. I can't take it. I can't take it. Let me hide this thing. I can't take it. So Control Z, undo. So what I'm going to do, what I can do is to put it on a group. So let me cancel that. Let me cancel that. Okay. By the way, before I do this, let me show you that even if I wanted to do the load being met on this line, it won't take it. But I can put it on a group. So cancel that. We have to go and create groups. Okay. Where do we create groups? It's not in the create scenario. It's in the where we mesh. So to go there, either you double click on one of these or just go to the model here. See that model? It'll take you there. And there is a group here. So we can do a manual group. The very first one, I'll call it left or clamped end. I'll call it clamped end. Clamped end. And the node, okay? I want that node. And this is the one. This is the one. Notice that one node was selected and it's going to go in that group. Good. So if you check on the groups, we have already created one which is called clamped end. And I also want all the elements on this line. So here, there are different ways of doing it. One is, of course, you can take them one by one, or you can say geometrical group. I want elements based on that. So I'm going to call this thing elements on the line. Elements on the line. And for the line, I'm going to select this line. And there's going to be, okay. So right here, let me update this thing. So it's created right there. And it will have 10 elements in it. 10 elements right there, because there were 10 elements there. Cancel. Now we're going to go to structure model, back to scenario, okay? And we're going to say, okay, let's go and boundary condition clamp. We go by groups. Clamped end right there. Make sure you left double click on it. It puts it there. And you go to load, beam load by groups. And it's the elements on the line. And it was a minus, I believe, 10. Right? Minus 10 pound per inch. Yep. Okay. So notice that when we did not join, we had to do it a different way. And in fact, let's go ahead and run it. I'm sure this is going to work fine. Let's go run it. I already alluded to this business of joining, etc., in tutorial number 2, I believe. So it may be helpful to look at that again at this stage. But anyway, this is going to run and we're going to get the same deflection. Our final strategy is to repeat the same problem, not on a sketch, okay, but simply on as a wireframe, as a line in space. And I'm not going to join it. It doesn't matter in that particular problem. If I join it, I'm doing some extra work. Everything is going to work fine. Okay. And if you look at the displacement, yeah, 0.714. Very good. So the third strategy is use a wireframe, do not join. If you join it, it makes no difference. Okay, so let me get rid of this. Let me get rid of that. Okay, start with a part file. Because I'm not joining, you might as well do it in a part design. Why don't I do it? It doesn't matter really. Okay, so you go to essentials, align. Why don't I do a point and direction? Let me create a point. Let me make this go further up. So I'll make it maybe just so that we can see it, 30 inches. Where is it? Maybe that was too far. Okay, that's fine. That's fine. And the direction is going to be in the direction Y and 120 inches. Okay, good. So here is my line. We're going to apply properties on it. We have already the same properties. So we go to Tools, Material Browser. And there we are. Join or not to join. So do it. Try it again. Yeah. Close that. Very good. And now we're going to go to the structure model creation to mesh. But remember, I just want to remind you that another way to get there is if you go all the way to the top level, right click, insert, finite element model. You do the same thing. But you know what? I'll go back here. Okay. All right, good. Empty FEM. Notice that this is not a sketch, it's a line, and I did not join. I could have. I mean, obviously, I have to go to shape design and then join it there if I wanted to, but I'm not going to do that. Mesh, B mesh, no problem. 12 inches mesh. And although I did not join, I can still create section. We'll see that. So we go to groups. Sorry, not groups. Properties. First of all, a profile, circular, 2 inches. Good. And then create a section. And if I remember in the previous strategy, I could not pick that sketch, but now I can. And profile is profile number 1. And we say, okay, very good. And finally, now that we're done here, we're going to go to structural scenario creation. Choose the FEM model. Okay, procedure is going to be static perturbation. In strategy 2, I could not even put a clamp here. I had to go and create those groups and things like that. But here, let's see now, under boundary condition, clamp, right there. And beam load, couldn't do it in 2. I can do it now. So whole line, -10. Say okay. And I'm going to run it. So I just wanted to shed some light on, issues like this that may haunt people. They wonder why it's not working. And in the next tutorial, which is tutorial 8, I will create the bending moment shear force diagram for this particular problem. And then later on, probably a second tutorial for a problem that's a little bit more complicated than that. But anyway, that comes later. No big deal. The deflection is going to be 0.714 inches. Should be. Right there. So look at the deflection, displacement, 0.714. Now, one last thing that I'm going to do, this is fine, except that I want to explain to you what does this mean, this thing. So if you want to see the node numbers here, because there's 11 nodes, what you can do is you can double click on that contour and says you go here, this tab here, options, node label, show node labels. Why? That's what this thing looks. All right, we're gonna need this in when we do bending moment and shape force diagram. That's it, folks. I hope you found